Hi, I'm Bob. Welcome back to 5 Minute Econometrics, a program focusing on fundamental econometric concepts and estimation methods. Today, we will look at the R-squared. We will see R-squared after regression in any software like Stata. The R-squared is a measure of the goodness of fit, or the explanatory power. It is sometimes called a coefficient of determination. It captures how much variation in the outcome variable y can be explained by the explanatory variables x in the model. R-squared equals the explained sum of squares, SSE, divided by the total sum of squares, SST. The numerator, SSE, is a measure of variation in the fit value, y hat. That is, it captures the variation due to the explanatory variables. The denominator, SST, is the total variation in y. R-squared is the ratio of the explained variation compared to the total variation. It can be interpreted as the fraction of the sample variation in y that is explained by x. Since the total sum of squares, SST, equals the explained sum of squares, SSE, plus the residual sum of squares, SSR, we can write R-squared as 1 minus the residual sum of squares divided by the total sum of squares. For the estimation equation y equals y hat plus mu hat, the definitions of the SST, SSE, and SSR are as follows. Although we can calculate the R-squared manually, statistics software usually reports it after regression. Here's an example of the demand for ecologically friendly apples. We regress the quantity demanded on the prices of ecologically friendly apples and the prices of regular apples. Stata reports the R-squared 0.0364, which means only 3.6% of the variation in the quantity demanded for the ecologically friendly apples can be explained by the own prices and the cross prices. We can also see the adjusted R-squared below the usual R-squared. The adjusted R-squared has been adjusted by the degrees of freedom. It is defined as follows. Compared to the usual R-squared, the adjusted R-squared imposes a penalty for adding additional explanatory variables to the model. From its formula, we know that the adjusted R-squared is smaller than the usual R-squared, holding other components fixed. If the number of explanatory variables, k, increases, the adjusted R-squared decreases. In our example, the adjusted R-squared is 0.0335. An important thing about the R-squared is that the size of it has nothing to do with the unbiasedness of the OLS estimates. The zero conditional mean assumption is the key to unbiased coefficient estimates. As long as the assumption is satisfied, no matter how big or small the R-squared is, our OLS estimates are unbiased. Return to our example. If the Apple prices were randomly assigned to customers, then the expenditure variables are not correlated to any unobserved or observed factors that can change the demand for the apples, meaning that the zero conditional mean assumption is met. Therefore, the OLS estimates are unbiased, even though the R-squared is tiny. From the R-squared form of the F-statistic, we find that the relative change in the R-squared determines the joint significance of the variables added to the model. We use the R-squared from the restricted model and that from the unrestricted model when we construct the F-statistic. For example, in our regression, we add the family income and customer age to the model. The F-statistic for the joint significance is 0.65 and the p-value is 0.52. So the income and age are jointly insignificant at any traditional level. We can also manually calculate the R-squared form of the F-statistic. The R-squared from the unrestricted model, the long model, is 0.0383, and that from the restricted model, the short model, is 0.0364. They are so close that the F-statistic becomes small. Notice that we use the usual R-squared instead of the adjusted R-squared in the F-statistic. Finally, let me wrap up today's topic by emphasizing 3 points. First, the definition of the R-squared. It is the proportion of the variation in y that is explained by x. Second, R-squared has nothing to do with unbiased estimation of beta. Third, the relative change in the R-squared can construct the F-statistic and determine the joint significance of a group of variables. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.